Greetings YouTubers, I am Rick the Tech Enthusiast here with a special video I'm calling SideTracked. You can probably guess from the title, it's when I get sidetracked with an alternate build or some cool new tech. This SideTracked video will be covering the Space Invaders U8g2 conversion. While working on the Elegoo Lesson 13, Analog Joystick Module, I got sidetracked by another great video series by XTronical covering his development of Space Invaders for the Arduino Nano. His Space Invaders uses the I2C OLED with the Adafruit SSD 1306 library and a customized ToneAC library. Now, after watching the series, I wondered if I could port his code to the Arduino Uno using my SPI OLED and the U8g2 library. And of course, I wanted to include the Analog Joystick Module. So in this video, I'll show you my gaming circuit, and I say that with quotes, my modified sketch with a few alterations, and finally, some Space Invader gameplay. In this lesson, we'll become familiar with the Analog Joystick Module provided with the Elegoo kit. Oops, sorry, force of habit. I should point out that the SPI OLED is something I bought separately. It's not originally included with the Elegoo kit. They're reasonably priced and they come in two versions, SPI and I2C. SPI displays require more connections, but it's my understanding that they perform faster and multiple displays can be added by just one additional data line. I2C displays require fewer connections, but have a minor performance hit, and multiple displays must have different addresses. For most of our projects, having one or the other display is a great addition to your Arduino hardware. Here you see the gaming circuit schematic. Unfortunately, I couldn't find the exact fritzing hardware, so I'm using the closest thing I can find. I start out with the OLED. Now it shows wave share now. I don't have a wave share, and my pinouts are close to what is shown here. More specifically is my pins line up almost directly towards the Arduino pins and then doesn't do all these extra crossovers like you see here. But I have to kind of use what's available to me. You can see that the DIN pin is actually the MOSI pin that would be used for the OLED. Now the clock pin goes all the way to D13, and that is the SCK pin. The reset, the CS, and the DC pins show all cross over here, but they connect to pins D8, D7, and D6. The joystick module switch connects to pin 2, and the analog pins connect to 0 and analog 1. The analog 2 pin is used as a digital input to the tactile switch, which I show here on to the left. Otherwise, it's just the passive buzzer, which is connected to pins 10 and 9. Now, I know that's sort of unusual to put it right in the middle of the OLED pins, but the ToneAC library is hardwired to use pins 9 and 10. So there was no exception. I had to use those if I wanted to use that library. I actually did try to use a different library, but turns out the XTronical customized the ToneAC library to include a new method called noise. And I wasn't able to replicate that in the ToneAC library 2, which allows you to put it on any other 2 pins. So I had to backtrack and make it work with the pins 9 and 10 and the ToneAC library. Here's the wiring diagram. Again, it shows the wave share OLED. I don't have this particular OLED. my OLED pinout, like I said before, lines up pretty straight into the circuit that I'm planning to use. So I just kind of had to customize this one to make it work for this schematic in the fritzing software. The joystick module is similar to this one as well, but the one in the kit and the pinouts are a little bit different. So if you're using the analog joystick module from the Elegoo kit, be sure to check your pins to make sure they're connected properly. Here are a couple little gotchas. As you can see, hidden below the OLED pins, I have a little jumper here that connects in between the tactile switch pins, which is basically the first and third rows. You have to use a little caution here, because if you accidentally, which I did, connect it to the first or the third row, it turns out the pins are bridged across that breadboard. So once you hit that switch, you will then ground out that particular pin. By putting it in between those pins, you can avoid grounding out that pin 9 or pin 10. On the bottom, you'll see that I had to use multiple jumpers, since I didn't have a single jumper that would reach all the way across to the tactile switch. So I tried to replicate what I had to use to make this work. Now, as I said, I think in maybe lesson 4 or 5, these little jumpers that I have that are pre-made is another separate purchase that I added because I thought it would make my circuits look a little neater than just the plain old big jumpers. And I think they do a great job. So I would recommend those too if you wanted to clean up your circuits a little bit. But the other thing, what's nice about these is you can hide several of these jumpers and the analog connections under the OLED once it's put into place. Now I show this in sort of an exploded view. The OLED is way up above the prototype board, which I kind of show here. It's sort of going to be laying on top of the Arduino Uno. And then I show the passive speaker off to the left here and the analog joystick on to the right. But the OLED will actually lay on top of the little mini breadboard there, and so will the passive speaker, hiding a lot of the jumpers there and really cleaning up the circuit. So a lot of the spaghetti mess that you see will be gone in the final arrangement of the prototype board. So let's check out the final assembled board. Here I have a photo of basically the final assembled board, only in sort of an exploded view so that you can see all the jumpers. It looks quite a bit neater than the wiring or the schematic diagrams. As you can see, the analog joystick is still connected with the female to male jumpers, with the access pins connected to the breadboard and the switch pin connected to the breadboard. Now the power and grounds will connect to the right hand side where there's some power and ground rails on the prototype board. What's hard to see, which is kind of covered, is just above the switch pin is a jumper that goes from the breadboard to pin 2. So that's a little bit hidden from this picture. I think I have a later picture that shows a little bit better. But then you can see pin 6 jumping to the breadboard, and 7 and 8. Now 9 is connected to the 100 ohm resistor that jumps to the breadboard to what will be the positive of the passive speaker. Jumper for pin 10 that goes to in between the first and third rows of the breadboard to avoid being grounded by the tactile switch will be connected to the other terminal of the passive buzzer. The tactile switch, we're really only using the bottom half of the breadboard to make the connections, but it is connected electrically on both sides. So that's why we have to be cautious when we connect our connections on the upper part of the breadboard. But to make the complete connection, I didn't have a pre-made jumper that was long enough that went all the way to the tactile switch. So I had to use a combination of jumpers to make it go all the way to the A2 pin that I'm using as a digital input. Analog 0 and analog 1 connects to these little jumpers across the breadboard that connects to the analog axis X and Y pins for the analog joystick. The blue jumper and the green jumper goes to what will be the positions for the MOSI and the clock for the OLED. The little two other orange jumpers here connect the ground and power, which I believe is actually, yeah, ground is on the left and power is just to the right of it. Above that is the Arduino Uno R3 board. The left is the passive buzzer, and then there's the SPI OLED. Let's assemble the whole circuit and check it out. Here's a photo of the completed circuit. You can see with the prototype board that's included with the kit, it becomes a very neat package. And what's really cool about this is later on I can pull off the prototype board and keep it aside and continue to do other circuits and then go back to it later on when I want to play a little Space Invaders or something else. Very cool. Let's check out the code. All right, here it is, the Space Invaders U8g2 sketch with its version 1.0. It uses the U8g2 library, modified by myself. Originally, this was made by XTronical using the Adafruit library. You can find the original sketch at his webpage or on YouTube. And the modified ToneAC Library is located at this webpage. The U8g2 library can be found here. And if you've seen any of my other videos that uses the OLED, I've already included that library and been using it for a while, so that shouldn't be a surprise. But in the libraries, we'll include the U8g2 library. The modified ToneAC library that will be from the XTronical website. As you can see, I originally tried to use the ToneAC2, and we're going to use a new library. It's the EEPROM.h. And why that's important is it allows us to store something in the Arduino's flash that will be saved, so when we turn off the Arduino, in this case the game, in this case the high score of the game, we can retrieve that high score even if the power is off or on once we restart the game when the power is back on. Very cool feature. I wasn't aware that was there. I found that from XTronical's website. A great thing to include if you needed something where it would shut down completely and be able to retrieve some data or number or value when it starts back up again. So here we continue on with the global constants, and then I included a little information, well, for myself and for anybody else reading it, why we would use the pound defined or just a plain constant. Now, in my previous videos, I typically would replace the pound defined with constants, but in this case, we're sort of memory lacking. There's only about, I think, 2K of memory available to run the program, whereas there's, I think, 32K of memory, if that's right. I'm sure some of you will correct me if I'm wrong, for the program to be uploaded to the Arduino. So the flash part of the Arduino is quite large and the RAM is relatively small. So we need as much of that RAM as possible. So we need to move that into the flash memory if it's a constant, since it's not changing. And the pound define does that for us. But there's another way of doing that, and that is using the prog-mem. I call it program memory, but the PROGMEM is a feature that allows you to move constant values into a flash memory. Now there's a drawback because there is I guess a speed penalty for doing that, but as long as it's just static memory, or I should say static is probably an improper term, as long as it's it's a constant value, reading it is relatively faster than if you're reading and writing to it. Now, the advantage of using the program memory function is that you can safely type define your variables there, where you can't type define variables using the pound defined. So anyway, I continue on with the OLED SPI constants, and I put those into program memory. And these are the integers for the pins for the OLED clock, MOSI, the reset, the data communication, and the component select pins. Now, I did have a long list here before, and I tried several versions of the U8g2 library to figure out what versions of it works better for my particular hardware. And originally I did try the SSD 1306, and I think I actually used that in a previous video, but I got some garbage that would show up on the right hand side. And it turns out I find there's a minor difference between the SSD 1306 and the SH1106 controller for each of these different OLED displays. And the SH1106 has just a wee bit more RAM addressable space than the SSD 1306. And by using the SH1106 U8g2 command to instantiate this class, that garbage is removed from the screen. So this is why I use the SH1106 for this function. And I use the OLED as the class object. If you are planning to use the I2C version, then I did include a couple of lines that I believe would work for the I2C. Now, I don't have an I2C display, so I'll leave it up to you to figure out how to properly instantiate that. And I assume somewhere in there there'll also be some kind of address that you'll have to define there as well. I continue on with the define screen width and height. Now this is the same thing that I believe XTronical had there, so it's really not a change. The big change is his input settings. He had fire, right, and left using different buttons, 3 different buttons. In my case, we are using the analog joystick, and I have the X and Y pins, and a tactile button for an additional button. Turns out that I kind of like using a tactile button versus the switch on the analog joystick, but you could use both, and both of them will work. The passive buzzer is defined by the ToneAC library. So when I originally was trying to use the ToneAC 2 library, I had to define the pins, but now they're predefined by the library ToneAC, and so I just remark these out. The other game constants, other than adding some additional remarks in here, really haven't changed. I might have slowed some things down or changed a couple little numbers to suit my needs, but otherwise they're pretty much, they remain the same as XTronical's code. So we'll just keep going down until the next change. Here is the next big change. Using the U8g2 library, I could not get it to work with the binary numbers that he created for his different space aliens and the mothership graphics. I had to take those, recreate each of those bitmaps using GIMP2 to convert those bitmaps after I recreated them to create the hex numerical values that you see there. Now, in addition, I decided rather than having two different versions of the different invaders, different aliens, I made a single variable with an array, a multiple array of the different positions that it will have. I also made a smaller version of the mothership so that there's two versions of the mothership as well. Going down to the global constants, I had to do the same thing for the tanks, the missile, the alien bomb, the bases, explosions. All of them had to be redone with the GIMP2 program, and then the hex numbers brought back in. Global classes, game structures. These structures were actually pretty much intact from the original XTronical sketch, so I didn't really change these a whole lot that I can remember. I think I might have gone through where I saw chars. I might have changed them to bytes just to try to save a few bits of memory. A char and a byte are basically the same, but I think bytes are better used when there's really just a number representation and not a character. So I changed some of these to bytes that were once chars. Going down to global variables, I think I left these pretty much the same as well. There's one change. I added a mothership type because now there's going to be two different mothership types. There's going to be the small one and the big one. I think in the global variable sound settings, I did move this music into program memory, trying to save a byte or two. As my memory was getting smaller and smaller, I started seeing little graphic glitches that would occur. So I went through and tried desperately to come up with different things to reduce my active memory footprint. Under the void setup, you can see that I try to keep some of the older code there. I did add the new OLED begin and the clear and the set bitmap mode to 1. The original code included the display begin SSD function to start the Adafruit library object, but obviously we don't need that here. So I just remmed it out to kind of show as a placeholder that this is where he had it, and this is where I've removed it and changed it to the U8g2 version. Under the pin modes, I have my new 2 fire buttons. One's a tactile switch and one's the analog joystick using the pull-up resistors. And then commented out the other button versions that were originally there. In the original Adafruit version, they had a text size 1, which defined some font, and I couldn't really find exactly what that font was, so I came up with something that I believe was close. So using the U8g2 library, I had to set the font to this font to get something that was the correct size for the display. And then I included this font ascent and font descent so that I can find just how far the font goes from its baseline up, and from the baseline as it goes below, like a G or the Y will have a part of the character below the baseline. And so I wanted to find that full height so that I can create a row height later on, and that way if somebody changes the font size, it could dynamically change the row height for the different player high score displays. And then I set the draw color to 1. Here's the EEPROM setup that is identical to the one that's in the XTronical sketch. So we'll just continue on. The void loop is basically untouched, so we'll continue onto the functions and subroutines. Under the tracked screen, this is where we had a lot of changes. The original display, clear display, was later replaced with, if I go down to the OLED clear buffer. I added 2 new local variables, the row height and row column, and that is to enable the usage of a different font, and it would dynamically center and move the text accordingly. This allows a little flexibility there. And I tried converting it to some of the values to strings and then convert it to array chars and something like that. And I couldn't make it work without consuming a lot of memory. So I just remarked that all out. And here I have this column position. I use this function called getStringWidth, and I get that string width. So now I can use that to find out just where I need to center or move the columns display. Now, in the high score, since that can vary from anywhere between 0 and 65,535, which is the maximum for an unsigned integer, I need to know just how many digits do I have so that I can correctly position or correctly center the high score in the display. So this series of if statements goes through and tries to determine how many digits there is in the current high score so that it can properly center it. As I said before, we do the clear buffer to clear the buffer, and that clears the screen. We have the row height, which is basically the font ascent, screen height, and we subtract 4 lines of text, and then we'll add the font ascent and the font descent +1, just to give, so they're not on top of each other. And then we divide that whole thing by 2, so we kind of get an idea where to start. Then we center the text using a center text function. I had a couple of next lines for some debugging, which allowed me to put some numbers next to it when I was trying to first figure things out. I can probably delete those now, but for future reference, it was just a nice place to put numbers right after play so that I know that when I was trying to figure out the column position, it would just be play, space, and then some column position that was calculated from above. The next, I do another row height to go to the next line, and then I center the text for Space Invaders, and row height for the next line. Each time I'm incrementing it by 1 full row height. And then I do press fire to start, and then another row height, and the last line, which would be what would be the high score. I use the custom column position, the last row height. I then just print the high score, and then print the high score, which is the variable stored up in flash memory. I send this to the buffer, which then displays it. And then I have this little feature that checks to see if one of the fire buttons have been pressed, which then will start the game and begin a new game. The rest of this function is the same as it was before, so I'll continue on to the physics. The physics didn't change, so moving on to the next thing that was modified. So under the void mothership physics, here it has a lot of the different features of the mothership, including finding out whether or not the mothership is active or to spawn a new mothership. If it is active, I wanted to determine what mothership was showing on the screen. So if the mothership is a small one or a big one, I wanted to change the tone like you would see in the original Space Invaders. I have in the smaller ship, I use the ToneAC command with this nice little feature so that it would kind of vary as it goes across. This is very similar to the XTronical, it's almost identical to the XTronical tone that he put out for the regular mothership. I just made it a little bit higher so it sounded like the little ship going across. If we scroll down, you can see where I made other changes where I thought I was going to use a ToneAC tube, which I didn't end up using. I ended up going back to the regular ToneAC. Here we go under the checking to see whether or not to spawn a mothership. It has this random mothership spawn chance equaling 1. That mothership spawn chance is defined above. Then if the random number does become 1, it does create a mothership status as active, and then it chooses what type of mothership. And here I've added this random 2. So the random 2 would select a value of either 0 or 1, and I use that to basically determine which array of mothership it will use, the 0 or the 1. The rest of this is identical to the XTronical website or sketch. Under the player control, I believe there was the only really change I made was originally the firing was using this noise, this custom method noise AC. Didn't quite like that. I like a little higher pitched tone for the firing of the tank missiles. So I changed it to a ToneAC with a higher frequency, and then since this one initiated a shoot complete Boolean value, I set that to true, just so that so other sounds could continue as a missile is being sent up to the aliens. Here's where the next change would be. I believe because of the difficulty of U8g2, I went through anywhere that had the binary values of what would be the graphics. I end up having to convert those to hex. So here I converted that to hex, and then but the rest of the logic pretty much stayed the same. Again, I changed this from binary to hex. Under the get alien base collision mask function, where they had the binary values, I did change those to hex values. So on the void update display, I had to change the original display, clear display, to the new OLED clear buffer. So this is where it would display the mothership bonus. I changed these to the OLED set cursor to print the bonus, and then use the OLED print to show the mothership bonus. Again, for the else, I showed the OLED set cursor to replace what was there before. Okay, here's I didn't see this before, but I believe if I missed it, I apologize. Everywhere that it had the original draw BMP, I had to change that to the new object class, which his object class was display, but his object was display, and my object is OLED, but its method was draw BMP, if I remember correctly, under the U8g2, anything that's been pushed up into to flash RAM or flash storage, program storage, we had to use a special method called draw XBMP, and that allowed the U8g2 library to access that those data bits there. Again, we had to do the same thing for the alien bomb. And anywhere else that we would display any of the graphics. So here's another one where we're doing some of the animations for the invaders. The invaders have all been pushed up into the program memory, and so we have to use the draw XBMP for that. And the draw XBMP for this other alien. And this case statement is for each of the levels of the alien invaders. Now he explains this in his video, so otherwise nothing has changed, so I'll leave the rest alone. Oh, there has been a big change. Okay, here's the big change. Originally, he had animation frames and whether or not it was going to be one alien movement or the other alien movement. And since I combined that to an array, I no longer need this if-else statement. And instead, I just commented that out. And now, I'm not sure if he had this the same, but nonetheless, here's the animation frame. Now, this if statement, I believe, checks a Boolean value. So if this Boolean value is true, it makes this J variable into a 0, else J is a 1. And why that's important is down over here, we have the top invader, and then this chooses which array of graphics it's going to display. So in this case, which is the first or second movement of the top invader. This is true with all the other invaders as well. The middle invader does the same thing, and the bottom invader does the same thing. So it eliminated quite a few lines of code, and it brought it down to just the one line for this case statement. Here's another draw XBMP for this other alien, and that's for the explosion. Here we have the player tank, I believe, and this guy uses the draw XBMP. Here we have the mothership. Here's a change. We have the draw XBMP. And now we have the mothership and the mothership type. And that is the number that was determined before when we were determining whether or not it was active. And that 0 or 1 value will show up here. And that will choose either the large or small mothership. All right, here's where things start to change a little bit. He explained in his videos that he had to copy the bases into regular memory so that way he can destroy those bases as the shots are being fired. Those tank bases were copied into regular playable memory or active memory, and so in order to access those, we need to use a draw XBM method, and that's going to be true with all the base graphics. So everywhere we have base graphics and where we're firing at the, looking at destroying the base graphics, whether we're firing through it with a tank or the aliens are dropping bombs on it and little bits of the bases are being removed, we need to use the draw XBM method. Under the void game over, it's more of the same text. I created a row height and the column position local variables. I go through basically the same thing where I replace the OLED clear buffer for the display clear display call that was made before. I go through and use the center text for all the different rows of text, with this column position to get the character of width of a number 8, and then I try to determine the number of integers, or sorry, the number of digits in the high score, so it can determine the appropriate column position. And then I set the cursor to that column position and row height and display the score and the player score. Now, here's where it was the same as originally before. If the player score is greater than the high score, it will then say new high score and congratulations, and it'll play a little tune. Those are all the same from the XTronical sketch. Here's another change. Under the center text was a different function, which I don't remember offhand what that was, but in this one I use the get string width method to determine the text's string width. Now that works really well for most text, but it doesn't work well with the high score. I'm not sure what was conflicting, but it would come up with some remarkably weird numbers for all those. So that's why I had to go to the extent of coming up with a new column position. Anyway, every other text that came through, we could use the get string width, find that width, and then center that string accordingly. All right, I think that covers most of what I changed. I believe I added another delay somewhere in there so that the screen would kind of show you where you died for like a half a second, so 500 milliseconds, before it went to the status of your score and how many lives you had left. I just thought the transition was too quick, too startling, and now you actually see your little tank getting destroyed. You sit there for like a half a second, and then it goes to the player status, and then it switches over to continuing the gameplay or game over. Otherwise, I think that pretty much covered everything in the sketch. Let's upload the code and check it out. Oh, one last thing. Under the ToneAC Library, the ToneAC.h file, there's another thing I did edit. Now, of course, I did add this line to let me know that this has been changed from what the one that was originally, or the one that was from the XTronical website. I got this little error that kept coming up. It was a minor error and it kept working. I had to change void noise AC. The very last variable that was passed is a Boolean completed, and it was set to equal false, if I remember correctly, but that kept erroring or providing a small error in the Arduino IDE. So I set that to equal 0, and the error went away. So it seems to be working fine after I made that small change and saved it. So you might want to make that same change as well. Well, I hope you've enjoyed this little diversion. If you like this kind of video, be sure to let me know in the comments section below. I'll have additional links for other interesting videos and the code for this project in the show notes below. If you like this video, don't forget to rate and subscribe. I'll try to put out a new video each week. Thanks, and see you next time.